And I'm the awesome tutor, and today we're going to be looking at trigonometric graphs and simple transformations of them. So here's the sine graph. Y is sine of x. Alright, as you can see, it's just a continuous wave. Alright? And here are the values on the x-axis, the important ones. Alright, because sine of 90 gives you 1. Sine of 180 gives you 0. Sine of 270 gives you -1. As you can see, the sine graph has boundaries, limits of -1 and 1. These are the maximum y values it can have. This is its range. Okay? That's why when you do inverse sine of any number that is smaller than -1 or bigger than 1, it's not going to work. It's going to give you math error. So, we can see from this graph that there is symmetry. Alright, symmetry about the 90 degrees, the 270 degrees, the 450. Alright, we have symmetry about the 90 degrees. Alright, any angle here we pick, the distance between that and 90 degrees, if we put the same distance but on this side, these two angles will give the same y value. Same thing here, if we look at 270, alright, the distance there, same distance here. These two angles, whatever they are, they will give you the same y value. Similar to how 90, the sine of 90 gives you 1, and the sine of 450 also gives you 1. And the sine of 270 gives you -1, same how the sine of 630 gives you -1. Alright? Don't get too confused by this, because this is mainly used for solving equations, but we're not going to talk about that in this video. Also, you need to know how to draw this graph in radians. Okay, that's easy. The 90 becomes pi over 2, the 180 becomes pi, 270 becomes 3 pi over 2, and 360 becomes 2 pi. Alright, I think you only really need to know memorize the radian values between -360 and 360. If they give you a bigger range, you can just work it out. So, from this graph, we can see that sine 90 minus theta is equal to sine 90 plus theta. That's because of the symmetry I was talking about. And here also, sine of theta plus 360 is equal to sine theta, which is equal to sine of theta minus 360. That's because the sine graph repeats the same shape, alright, in periods. So, it repeats this shape, okay, and then it repeats it again and again. Alright? From 0 all the way to 360, and then repeats it again. That's why we have the value 360 here, because it repeats it every 360 degrees. That's why we have this. Okay? So if you add 360 to an angle, it's going to give you the same y value. And if you take away 360 from that angle, it's going to give you y value, because it's in the same position in the period. This angle here, if you add 360, it's going to be there. Take away 360 from this angle, it's going to be there. Alright? You're in the same position in the period. That's why they give you the same y value. So, let's move on to the cosine graph. Okay, so the cosine graph is basically exactly the same as the sine graph, but translated by 90 units to the left. Okay? That's why we get these identities. Sine theta is cosine 90 minus theta, and cosine theta is the same as sine of 90 minus theta. Because the cosine graph exactly the same as the sine graph, but translated 90 degrees to the right, to the left, sorry. Okay. Same as the sine graph, it is periodic, okay? It repeats every 360 degrees. Repeats this period, alright? From 0 to 360. Repeats this every 360 degrees, so we have the same identity as the sine one I showed you earlier. Also, we have symmetry on the negative x-axis and the positive x-axis. Cosine of negative 90 gives you 0, and cosine of 90 gives you 0. That's why we have this. Cosine negative theta is the same as cosine of theta, because from the origin, it's symmetrical. Okay? It's not a very good drawing, but you get the point. Okay? Let's move on to the tangent graph. Now the tangent graph is a little bit different. Okay? It looks like this, and it has asymptotes. Alright? It has asymptotes every 180 degrees, starting from negative 90. Alright? The dotted lines are where its asymptotes are. And as you can see, there's no symmetry here. Okay? And because it is periodic, just like the sine and cosine graph, alright? The pattern repeats every 180 degrees this time. This is the pattern. The angle here and the angle here, alright? These angles give the same y value, just like the sine and cosine graph, right? But this one's much easier, because the angles which have a difference of 180 degrees between them will be the angles that have the same y value. So that's how we get tan theta is equal to tan theta plus 180 degrees. Alright? Or tan of theta minus 180 degrees. Just like the sine and cosine, theta minus 360 and theta plus 360 is the same. Okay? Same thing here, but with 180 degrees. Right? The angle here, you add 180 degrees, it will give you the same y value. Okay? And also, the tan graph does not have limits for the y values. It does not have a limited range. Okay? It doesn't go up to 1 then stops, doesn't go up to a negative 1 then stops. It goes on forever, but never touches the asymptotes. Alright? Alright, so this is just a graph of combining the graph of sine, cosine, and tan, just so you can see what they look like together.